One, go.
Today we're going to be working with moles and compounds. So for today you'll need a periodic table, you'll need a calculator or your phone that has a calculator on it. Our previous section was on moles and atoms and or elements or single elements. Today we're going to go look at compounds and formula units. So when we were working before, we would have we would say if I had copper, I would go to my periodic table and I'd say copper has a mass of, and you would tell me by utilizing your periodic table, copper would have a mass of 63.5461 atom versus 1 mole. Does anybody remember what AMU stands for? Please remember what this is. Atomic mass unit. It's based upon 1/12 of a carbon atom. Okay, but notice here we have 63.546. When you did your bean lab, that was the whole point of it. They had you base everything on the smallest bean, which was I think, the lentil, and you just correlated everything. How many beans made up a relative mass, and that's exactly what they did when they were doing utilizing this or trying to find the masses of all the elements, and it worked out perfectly like this. The same thing is going to happen with a compound. So we're going to take a formula unit. Since we already have copper up there, we have copper 2 carbonate. All right, and first thing I have to know is how many grams is this, or AMUs is this? So I'm going to count. I'm going to say copper. There's 1 copper in this compound. There's 1 carbon in this compound, and there's 3 oxygens in that compound. Yes? So take 1 times this, and it's 63.546. This is 12. I need to look that up. 0107. And oxygen is 15.9994. So I'm going to hand you down a little calculator. I'm going to figure this out. Take 63.546 plus 12.0107 plus whatever 3 times this is. Just take your time to do that.
Are those arrows? Are those arrows?
How much did you say?
What?
How much did you say, Michael?
123.5549.
Okay. You're going to get some strange number like that?
Mrs. Wells, are
Yes.
those arrows?
Yeah. However, my original problem, let's say I want my original problem, this is okay, we can do that. And I'm going to transfer it over to moles. So if I have 3.2 moles of copper 2 carbonate, and I know that this many grams is 1 mole of copper 2 carbonate, how many grams do I have with 3.2 moles? When solving a problem, the first thing you do every single time is write down what you know. 3 point, what they give you. Using dimensional analysis, if I have moles of copper 2 carbonate up here, what label goes down in the denominator? If I have moles of copper 2 carbonate up here, what must go in the label down in the denominator? 1. Must be the same thing, moles of copper 2 carbonate. I know that 1 mole of copper 2 carbonate is 123.5549 grams. So I take that number. Do you have it saved on your calculator or not?
No.
Okay.
Wait, I can do that.
Okay. Okay, I multiply those two numbers and I times 3.2.
395.
How much?
395. 0.37568.
Right, that's what I would get on my calculator. However, because I started with how many significant digits?
2.
2. My answer can only have
2.
2. So what's my answer going to be with only 2 significant digits? Many of you would go, well, for 3 significant digits, it would be 395, correct?
Mm-hmm.
All right. Now what's going to happen?
40.
Okay.
Yeah.
Not 40. We have, because it's 395, it has to be 4. And what, remember I put that little symbol above it to show that I counted that 0? Or I can write it as 4.0 times 10 squared grams. Yes?
Mm-hmm.
Kind of tricky there. I did that on purpose, hoping that it would eventually, once the examples are going through, it would do that. This is not any different than what we did with the single elements. It's the same thing, except you're working with the molar mass. You're working with more numbers. We're going to try a couple more, and that will conclude our lecture time. Again, remember, for those of you who are here, this is on video, so if you need to get onto it, it will be published. Are we good?
Yeah.
Good? Liz, you good?
Yeah. I don't have the bottom part.
Okay, so but I can go up here so I can start a new problem.
Yes.
Okay, here's another example. Again, this is manipulation. After this chapter, we'll probably never really address particles to this extent again, maybe a little bit in the gas laws, but more likely than not, we're not going to touch on it, but we're going to use these problems to improve our math skills, all right, and how to do these. So I am looking at 7.38 times 10 to the 21st molecules of carbon dioxide, and how many grams is that? Right. Because I'm looking for grams, I need to find the molar mass of carbon dioxide. Okay? So maybe on my side note over here, I'm going to put a carbon, and there's one of them, and oxygen, there's 2 of them. This is 12.0107 times 15.9994. 12.0 29. No, what is it?
Yeah.
Is it 29.888? 8, whatever.
I got 31.9988.
Okay, 31. I'm sorry. Can't count. 31 point. Tell me.
9988.
Like that?
Yeah.
Okay. So I have that, and I add them together.
44.0095.
44.
0095.
All right. So that would be my molecular mass. So I have this information, which is going to be important when I want to do my dimensional analysis. 7.38 times 10 to the 24th molecules was what was given. Using dimensional analysis. All right, let's go back and think about if I have molecules up here, what must my label be down here? Molecules. So what number do you know that goes with molecules? What's Avogadro's number? 6.2 times 10 to the 23rd molecules is 1 mole. Now this should be in your notes somewhere about this factor conversion. Molecules, particles, atoms, whatever it is 1 mole, correct? So now I have this is molecules, that's molecules. Is it coming back? I know we've had a long weekend. Is that coming back?
Mm-hmm.
Right? From that, we have moles of carbon dioxide. What label goes down here? Label. What label? Moles of carbon dioxide. What label goes down here? Right. Moles of carbon dioxide. I know that I just figured out previously 1 mole of carbon dioxide is 44.0095 grams. All right. Now, what is the hint I gave you when you want to plug this into your, like, especially your iPhone or your phone calculators? Using parentheses. So you're going to go parentheses 7.38, and then you have that EE button, or E button, right? 24 parentheses times 44.0095 on your phones, finding out that best to press enter or equals or whatever it is, right? Then take that answer divided by parentheses 6.02, the EE button, 23 parentheses, enter or equal. And the magic number is for those of you who are watching the video, you can stop the video and or continue watching and determine what the answer is going to be.
Well, is he any headphones I can borrow?
I ended up with 539.5. Is that what you ended up with?
I don't know. I really have time, sorry.
Okay.
No.
Okay. Anybody else doing their calculators or a phone? Philip, are you doing it?
Yeah. I get 539.518 something.
Okay, that's what I end up with. Why is that the answer?
Because you wrong.
Because why do I have to round? What am I looking for? What is that called? What am I concerned about? How many digits did I start with? 3, correct?
Yeah.
How many must my answer have?
3.
3. All right. At this time, I'm going to stop the video and I'm going to give you assignments for the week.